Hello everyone, welcome everyone to this presentation on enhancing SDN security using Ensemble-based machine learning approach for DDoS attack detection. My name is Abdinasir Hirsi. I'm the first author of this research article, and this research is collaborative effort with my uh, supervisor, Professor Madhya, Dr. Lukman Hanif, and my co-supervisor, Dr. Adeb, Salh, and others from leading universities like Tabuk University, Dr. Mohammed, and Salman from UTHF. So this study is focusing on addressing the critical challenge of software-defined network, the detection and mitigation of DDoS attacks using innovative machine learning techniques. So we know that SDN is offering a flexible and programmable network framework, but the centralized architecture is highly vulnerable for DDoS attacks. So our research is proposing an ensemble-based machine learning that combining PCA for feature selection to enhance the detection accuracy. So a key novelty of our work is introduction of public accessible dataset to solve reproducibility challenges in previous studies. There are some existing works that have utilized uh, generated dataset, but it is not accessible for everyone. So our dataset is accessible for everyone, and we achieve outstanding results with our Ensemble random forest model, attaining up to 100% accuracy in detection of DDoS attacks. So when it comes for the introduction of our article, obviously, if I brief overview the DDoS attacks, as you can see this figure 1, this is the flooding DDoS attacks to the both data plane and control plane of the SDN. So these attacks deny users to access to the surface by overwhelming system with traffic, and modern attacks including both low and high rate DDoS attacks, and that will make the system more complex. So challenges in SDN, obviously there are a lot of challenges, although we know there are a lot of advantages of SDN controller, but it creates a single point of failure. This will make an attractive target for the attackers. Okay, since in the SDN we have a single controller that is managing all the network, the attackers get attractive to attack to the network. So our research introduces a simple machine learning framework to improve the detection accuracy and robustness of the system. And PCA is employed to optimize the feature selection and reducing dimensionality and computational overhead. Okay, and our key contribution of our study is combining classifiers through Ensemble learning for better accuracy, addressing reproducibility gaps with the novel dataset, and providing a comparative performance analysis against the established datasets like CISCA DDoS 2019. So if I discuss about the related work, recent researches on DDoS detection has leveraged machine learning and Ensemble methods, and improving detection rates and reducing false positive. However, these approach, there are a lot of you know challenges and still gaps we found from these studies, and these limitations are like mostly they rely on synthetic data set that are inaccessible or poorly documented. Okay, poorly documented. And second gap we found is feature selection method is often failed to optimize performance effectively, and some studies they lack uh, the diversity in attack scenarios and making the solution less robust in real-world applications. Um, our work directly address these shortcomings or these limitations by introducing a transparent dataset and optimized feature selection with PCA. So when it comes for the framework, if I uh, provide overview about the framework, as you can see, figure two, uh, the proposed framework comprises 8 phases. Okay, number one, first phase is dataset collection, as you can see here, and here our dataset, the name of our dataset we call SDN DDoS traffic dataset, SDN DDoS traffic dataset, which contains over 1 million rows generated using Mininet with tools like mchain and hping-3 for traffic simulation. And second phase is pre-processing, and this step will ensure data quality by handling missing values, okay, and normalizing imports. And third phase was feature selection. As you can see here, feature selection. This is the third phase. We use PCA to reduce dimensionality to 20 features. We have more than that, up to 26 features. After using PCA, we have 20 features to enhance model efficiency. Okay, and then next phase or phase number 4 is in simple method selection, and random forest was choose for its ability to handle large dataset and achieve high accuracy. And then a next step, which is phase number 5, was hyperparameter tuning. And parameters like the number of estimators and uh, tree depth are optimized for random forest. Then next step was training and testing, which is phase number 6. Um, we split 80 to 20 ratio to ensure robust model validation. Okay, and evaluation metrics like accuracy, precision, and F1 score. We measure the model's performance. And then next, last step was comparison with existing studies. The results were benchmark against the existing models to demonstrate the improvements. Okay, so this structure of approach ensures a robust and reproducible methodology for DDoS detection in SDN. So if I come to the experimental setup and performance evaluation, if I talk about the tools and metrics, we use it Skidland for implementation, and these other tools. With the performance measure, we use accuracy, precision, recall, F1 score, and etc. etc. For the results. And as you can see here, this figure 3, Ensemble random forest achieves perfect accuracy up to 100% of all other matrices, and with zero false positive or false negative. Also, we tested the other models like SVM, and for example, as you can see here figure, the accuracy of SVM achieves up to 99.9%, while XG Post reach 99.74 and demonstrating strong but slightly lower performance than other models like Ensemble Random Forest. We believe that PCA significantly improved the model performance by reducing noise and irrelevant features. Okay, after using the PCA, we have 20 features, and before that, we have more than 20 feature selection, 20 features. So comparison with baseline, uh, uh, when we compare our results, we found that Ensemble Random Forest outperformed traditional models like GLM with struggling with the complexity of nonlinear patterns in the data. Also, Ensemble methods like GP and PA performed well, but were slightly lower or less accurate than Ensemble Random Forest. Impact of PCA. We believe that PCA played a critical role in improving the performance across all models by reducing the feature space while preserving key information of the model. Uh, if I go back, okay, let's move forward. So now, uh, if I talk about the comparison of with existing studies, as you can see here, this table, um, uh, using Ensemble Random Forest, it stands out because it leverages multiple decision trees and improving both detection accuracy and resiliency to overfitting. Okay, and this is validating by the public accessible dataset and ensuring reproducibility, unlike many prior studies. So we believe this model, Ensemble Random Forest, adapts well diverse attack scenarios and provides a robust protection against the DDoS attacks. So, what are the key takeaways of this research article? Ensemble Random Forest is proving that optimal solution for detection and mitigating DDoS attack in SDN environment. And the second key takeaway is our public available dataset ensures transparency and reproducibility in our future research. Okay. So the future work uh, and future direction is after this article will be expanding the dataset with real-world traffic scenarios to improve generalizability, exploring advanced feature selection methods beyond the PCA to further optimize model performance, investigating the adaptability of this approach to other types of cyber threats. Okay, and obviously, this research will contribute significantly to the SDN security and offering a reliable and efficient solution to DDoS attacks. Uh, these are some references of the paper which we have cited in our research article. Uh, all the lists can be found in the article. I would like to acknowledge to the Minister of Higher Education for funding this research through Fundamental Research Grant Scheme, FRGS. Also, I would like to thank my supervisor, Professor Dr. Lukman, and my co-supervisor, Dr. Adeb Salh, and other collaborators and institutions for their support and contribution of this project. Thank you.